Hello guys, welcome to another section of Learning with Prepclass. I am Tutor Chima and I will be taking you guys on chemistry. So today we are going to be looking at Waec past questions 2019 on chemistry. Today we'll be looking at questions, or we'll be solving questions 11 to 15. Yes, because in our previous videos we've looked at questions 1 to 10. So today we'll be solving questions 11 to 15. So students, first and foremost, do not forget to subscribe to our YouTube channel. When you look below there, you see a notification bell. We advise you to hit the notification bell so that you'll be the first to always be notified whenever we have such content on our channel. Like our videos, share our videos. You also look below there, you are going to see a comment section. We urge you to drop 1 or 2 comments on our comment section box. The comment can be a question, maybe there is an area that is not that is not clear to you, you don't completely understand. You can just do so by dropping a comment or dropping a question. Okay, so without wasting your time today, let us go straight to the business of today, where we'll be solving past questions on Waec Chemistry 2019 11 to 15. Now, question 11 says, how many moles of carbon dioxide contains 16 grams of oxygen? How many moles of carbon dioxide contains 16 grams of oxygen? They've given us the atomic numbers: carbon 12, oxygen 16. Okay, is it 0.20 mole, 0.25 mole, 0.40 mole, or 0.5 mole? How many moles of carbon dioxide contains 16 grams of oxygen? Now, you must know that 1 mole of CO2, that is carbon dioxide, contains what? 12 of carbon. Let's go back, look at the atomic mass of carbon is 12, oxygen is 16. So 1 mole contains 12 of carbon plus 2 atoms of oxygen. That's 2 times 16 plus 16 times 2. So this will give us 12 plus 16 times 2 is 32. 32 plus 12, 44. Okay, so that's 44 grams. So now here we see that 1 mole of carbon dioxide contains 16 grams. That's 16 times 2 grams, which is 32 grams of oxygen. You can see from carbon dioxide. Carbon is 12. Oxygen is 16 times 2. So the 16 times 2 is 32. So 1 mole of carbon dioxide contains 32 grams of oxygen. So therefore, the number that will contain 16 grams of oxygen is supposed to be half of this 32. Remember that in the mole, we usually define the mole as the number of elementary entities as it is in exactly 12 grams of carbon having an isotope, or of carbon having an atomic number of 12. Remember that this 12 grams of carbon, or this carbon 12, is usually used as a standard for measuring 1 mole. So taking this carbon 12 as a standard for measuring 1 mole, if that 1 mole contains 32 grams of oxygen, therefore we can now be sure that the amount that will contain 16 grams, which is half of this 32 grams, will be half. It will be half mole. So therefore, the number that will contain 16 grams will be what? 16 over 32 times 1 mole. So 16 over 32 is what? 0.5. 0.5 times 1 is 0.5 mole. That is half. So the number that will contain this 16 grams will be what? Half. Will be what? Half, because 16 is half of 32. So the number that will contain that 16 grams will be what? Half mole, which is 0.5 mole. So your answer is 0.5 mole. Okay. Question number 12. Stoichiochemistry is based on the law of is it multiple proportion? Is it constant composition? Is it conservation of energy? Is it conservation of mass? What is stoichiochemistry? What is stoichiochemistry? Stoichiometry, sorry, I'm even calling it stoichiochemistry instead of stoichiometry. So it's actually stoichiometry. Stoichiochemistry, just like entering my mouth. Stoichiometry. Alright, so stoichiometry deals with the application of a balanced chemical equation in performing calculations involving mass and the mole. And a balanced chemical equation is based on the law of conservation of mass. So there is an aspect of chemistry, the aspect of chemistry which will solve mass and the mole, which is mole concept, is under the stoichiometry. And in this stoichiometry, it is usually required that we use a balanced chemical equation to determine the mass or the mole of a particular substance. One might be given, let's say in this reaction, they may give us the mass of ethine, and they may ask us to find the mass of carbon dioxide produced. So ability to do that, or that aspect of chemistry, is known as stoichiometry. So it involves mass and mole concepts. And for you to do that correctly, the chemical equation of that must be a balanced one. So stoichiometry must be a balanced one, must be a balanced chemical equation. And a balanced chemical equation is based on the law of conservation of mass, which means that what matter can neither be created nor be destroyed, but can be converted or transformed from one form to another. Now, if you look at this equation, the number of these entities at the reactant must be equal to their number on the product side. So if you look at here, for carbon, 2 times 2, carbon is 4 here. Then on the product side, it is still 4, because this 4 is for both carbon and oxygen. So here is 4. Carbon is balanced. Hydrogen is 2 times 2 here, which is 4. And here it is 2 times 2, which is 4. Oxygen is 2 times 5, which is 10 here. And 2 times 4, which is 8 plus 2, 10. So that there will be no net loss of what material. Do you understand? So that tells us that what matter can neither be created nor be destroyed, but can only be converted from one form to another. Ethine can be converted to what? Carbon dioxide. And oxygen can be converted to what? Water or steam. So the answer is law of conservation of mass, or law of conservation of matter. Whichever one. Question number 13. What is the percentage by mass of hydrogen in CH3COOH? What is the percentage by mass of hydrogen in CH3COOH? And they've given us the molar mass of CH3COOH as 60. They are now asking you to find the percentage by mass. Okay? Is it 1.7%? Is it 5%? Is it 6.7%? Is it 7.1%? Okay, now, if you look at CH3COOH, you see that there are 4 atoms of hydrogen. Look at this hydrogen here is 3 atoms plus 1 here, that is 4, giving you 4 atoms of hydrogen in this compound. So percentage composition becomes the mass of that number of hydrogen atoms, or let's say the molar mass of that 4 hydrogen atoms divided by the molar mass of the whole compound times 100/1. Very simple. So that 4 atoms of hydrogen divided by the molar mass of the entire compound times 100/1. That is very simple way of getting percentage composition. So since hydrogen H is 1, that becomes 4 times 1, 4 over, they've given us ethanoic acid. This compound is actually ethanoic acid. They've given us ethanoic acid, which is 60. So 4 over 60 times 100/1, and when you do that maths, you get 6.6666. So the 1 decimal point, that will give us 6.7%. So the answer is 6.7%. Very, very simple. Very simple. Question number 14. Which of the following compounds has coordinate bonds in the structure? Which of the following compounds has coordinate bonds in the structure? Now, they gave us aluminum chloride, magnesium chloride, silver chloride, and sodium chloride. All these compounds look more of an electrovalent compound. But you must note that aluminum chloride is a covalent compound, funny enough. Aluminum oxide is an equivalent compound, aluminum hydroxide, an equivalent compound, aluminum sulfate, but this aluminum chloride is a covalent compound. So all the compounds above are electrovalent in nature except aluminum. Please take note that aluminum chloride is covalent in nature. It is covalent in nature. It is not electrovalent. So aluminum chloride is a covalent compound and not an ionic or electrovalent compound, because aluminum atom has higher polarizing power, which attracts the Cl electrons easily and causing electron sharing. Though this is not much of a reason, but just note that aluminum chloride, instead of being an electrovalent compound, it's a covalent compound. It's covalent in nature, but when you dissolve it in water, it behaves like an electrolyte. So aluminum chloride is covalent in nature, but when you dissolve it in water, it has the ability of conducting electricity. So aluminum chloride is covalent in nature according to that bonding. Question number 15, and I believe that will be like the last for today's section. The name of the compound CH3C into bracket CH3 into bracket 2 CH2 CH2 CH3 is it 2-methyl butane? Is it 2,2-dimethyl butane? Is it 2-methyl pentane? Is it 2,2-dimethyl pentane? Before you can name this compound, or to make it very easy for you to name, you need to open this up. You need to open it up. So this CH3 is CH. You can see the 3 atoms of hydrogen. One here, one here, one here. Then a bond, one bond. So this is CCH3 into bracket 2. Now, this second carbon atom has 2 CH3 attached to it. And carbon being tetrahedral, carbon must have 4 bonds surrounding them. So since this C has 2 CH3, so one here, the other bond is joining with this carbon here, and the other bond is joining with this carbon here. That will give us this. So this C is this one. This CH3 are in twos. One is here, one is here. So the other bond will join with this C, and this other bond will join with this C here. I believe you understand. So this C is this C, then this H2 is this and this. Then this C is this one, then this H2 is this and this. Then this last C is this one, and this CH3 is this. And the last bond is joined. So this is an alkane. So now for us to name the compound, we use the numbering system. And for you to number, you number in such a way that these attachments, this is the methyl group or the alkyl group, has the lowest possible number. You number in such a way that this attachment, that's the methyl group, has the lowest possible number. Now if you number from behind, you are going to be numbering 1, 2, 3, 4, 5. That will now give this methyl group 4, 4, 4, 4, which is wrong. So you have to number in such a way that the methyl group will have the lowest possible number. So that's why I numbered from the front. 1, 2, 3, 4, 5. Remember that if this methyl group is here, I will number from behind to make it 2. Do you understand? But because it is here, so that's why I numbered from forwardly to make it what? Have the small number of 2 instead of numbering from behind to before. So you can number anywhere, either from forward way or behind, reversed way. But you have to number in such a way that this methyl group will have the lowest possible number. So that's why I numbered this way. So that's 1, 2, 3, 4, and 5. So the parent name is pentane because it has 5 carbon atoms. 1, 2, 3, 4, 5. And there is no double bond. Alkanes have single bond. So 5 is what? Pentane. The attaches are in the second carbon atom, and there are 2 methyl, 1 and 2. So 2, 2, 2, 2. This one is in 2, this one is also in 2. That's 2, 2. If one is here and one is here, becomes 2, 3. If one is here and one is here, becomes 2, 4. Do you understand? But the both of them are on the same carbon atom. That's why it's 2, 2. So that's 2, 2. And there are 2 methyl groups, which is dimethyl. So that's 2, 2 dimethyl. So you name the attachment before you now join it with the parent name. So the correct name becomes 2, 2 dimethyl, then the parent name pentane. So that's 2, 2 dimethyl pentane. And that will be your correct answer. 2, 2 dimethyl pentane. So that's the best answer, 2, 2 dimethyl pentane. So students, I believe you enjoyed this section of learning with Prepclass, where we look at Waec past questions on chemistry. 2019, we look at questions 11 to 15. If you look here, you're going to see a link. We urge you to copy and paste this link on your browser. It's going to land you straight to our WhatsApp group. It will take you straight to our WhatsApp group. So when you join our WhatsApp group, you'll be getting updates and infos on the latest video we have on YouTube. So till we meet again, I remain Mr. Chima, a Prepclass tutor on chemistry. Bye, and do stay safe.